Wondering if this is a different time than normal for
Yes,
people
it is
outside
for
the
us.
US.
It is for us in the UK for sure. It's an hour earlier.
Okay. Yeah, we changed our clocks this weekend. And I guess you guys don't do it for another couple of weeks or so.
Something like that, yeah.
Would be nice one day to not mess with the entire concept of time for
Hi. I have like short question. We change the time because it's daylight saving, right? Because for me it's like shifted. Okay. I was wondering what happened why it shifted 1 hour.
yeah, we just changed clocks in the US this weekend.
Huh.
Should we get started? Yeah, so since the last meeting, a couple of developments. Benji has a new proposal. Do you want to start and walk through that a little bit?
Yes, sorry, lost my unmute button. Yes, I can absolutely do that. So just over a week ago, as you know, a couple of weeks ago, I proposed that I thought that it would be reasonable to follow the existing field merging algorithm in GraphQL, which turned out to be more challenging than I first expected. And I sort of presented a really early version of a PR to the spec to do that, but it was fuzzy in a lot of regions and wasn't even really a first draft or anything. It was quite raw. I spoke with Lee later that week to unpick what it was that I was struggling with there, what it was that I was trying to say. And Lee did help me with some whiteboarding to figure out exactly what it was that we were trying to say. And what I hadn't realized is what it comes down to is effectively seeing all of the defers at one layer as a boundary, rather than looking at each individual selection set as a boundary. So if you think of doing field merging across the document, effectively, as you walk through each of the selection sets, you can assign each field into one of three states. Either this field is a regular field, which is going to be used right now, which is like the state for everything in GraphQL right now, right? We always use every field unless there's like a skip or include directive. The other state or another state is this field is to be streamed. And I believe that the validations that we have in place at the moment are if a field is to be streamed, or if it has the stream directive, then every instance of that field must also have the stream directive according to the validation rules. I think that's right. Is that right, Rob?
Yeah.
Yeah, cool. And then, of course, the third one is this field is to be deferred. Now, the interesting thing with defer is it doesn't, unlike the stream, it doesn't have to match. So you can have like username in one fragment that's used immediately and username in another fragment that's deferred, and that's fine. Effectively, well, actually, that's what some of the discussion is around. Should we deliver it in both cases, or should we only deliver it in the upfront case kind of thing? So what me and Lee figured out was effectively, if we follow that field merging strategy and then we assign each of these fields to one of these three things, do it now, stream it, or defer it, then what we can do is when we look at each of the fields with the same response name, effectively the same path, like username, for example, we can say, well, this one says to use it now, and this one's deferred. So the use it now wins, and we just put it into the use it now bucket, and we forget about the deferred bit. We still use the selection set from the defer later, but that's a separate thing. So effectively, we walk through the entire thing, we pull out everything that's to be done now, and we execute that now. And then for the rest of the things that weren't executed, we add them to like a second phase, a second layer of execution. And we group them all together, even though they're at different paths. So if you have a look at, let me just share my screen. Hang on a second. Zoom up the font size a little. Share this one. Can you see the RFC alternative proposal 1018?
Yep.
Cool.
Yep.
Perfect. So the idea is this. If you've got a query like this one, we look through it, we see A and B are right there. They're not inside any defers. C here is inside a defer, so we'll ignore it for now. D is not in a defer, neither is E. Same goes for G, and all of this is deferred. So we pull those non-deferred bits out, the A, D, B, E, and G, and they effectively are executed then as the first thing, and that's sent as your first response. Then, and here's an example of that. We'll go back to that in a moment. Then we look at the next layer of the stuff that was deferred. So here, this is a C field, which has got one defer. We've got an F here that's got one defer, and we've got the A, C, and H here that have got one defer. We ignore the C2 here because it's effectively deferred and then deferred again in another selection set. So this will be ignored. And it means that at the root path, we're going to run the H here. The A was already executed up here, so we don't need to run it again. But the H does need to be run, and that's the only thing at this layer that needs to be run in this second phase. So we run that at the root level separately, and this is the sort of different thing. At path A, we then need to run its selection set. So that's this defer here. This C field was never run previously. So we need to run this C field here, and we'll do C, C1. And we've also got the C field here, but its selection set is deferred. So this doesn't actually add anything. So we're just going to run the C, C1. And that's at path A. So we'll run that selection set and store that as the result for that. And finally, at the AD path, there is an F field, which is here. So this was deferred before. So we had the A, we had the D, but we didn't have the F. So this will come in at this AD path. And then finally, for the third round, we'll look at whatever's remaining after that, which is this C2 that's at the root AC path. So that will come through as the final thing, AC with the C2. Now, importantly, we don't want to break anything to do with like the fragment consistency. And so what is absolutely critical here is that even though these are three different things, three different selections to be ran, that kind of thing, they must be delivered together. So they're separate objects, but they must always, all of them, be in the same incremental total payload for the incremental. And that means that we effectively say you must apply all of these. Oh, that should be a closing square bracket. We should apply all of these all at once. And then once that's done, then you can, do a render or write to the cache or whatever it is that your client needs to do next. And that helps us to ensure consistency, so we don't break things like Matt's dunder type name, this fragment has been loaded hack, or any other future things that we want to add like that.
How does the server know to couple those together?
It's just part of the specification. Like it's written out in the execute selection sets, effectively. All of this is. So this is all following the spec text that I have written in this PR. And that's essentially it. On top of that, so the initial payload comes with its data, and then I've added the pending, which is much like what we discussed, a few months ago, to say there is data that is pending at the root level path. Now, we know that there's actually three different things that are going to be coming at different paths, but that doesn't really matter. Like, all that matters is telling the client that the root level path isn't complete yet, and there's going to be a next payload. Once we have resolved all of that, we send all the data through and we say we've now completed that ID 0 pending, but there is now another pending, but the root level is done now, as is the root level A. The only thing that is now pending is at the AC path. So we say at the AC path, there is a thing that is pending, and then we'll deliver that when we go and process that, and we'll say that's complete. And then finally, we'll say there's nothing else to come. This has next true here should technically be a has next false. It's not a big deal, we can have it either way. But at the moment, this is one of the issues in the spec text, is that it doesn't have the mechanism to figure out at this point that it can be has next false. So we just do it in a final follow-up pull request. But that's essentially it. So it's done based on these defer layers. So the great thing about this is all, so this is a pull request that is created based on the current state of the GraphQL spec, so the latest draft. It's not based on Rob's previous work, which means it doesn't have any of the validation rules that Rob's already prepared or any of the other text that we absolutely need, just to be clear. And that's just because I wanted to make the diff as small as possible, as to show what the difference between the algorithms for this and the algorithms for the current draft are, without factoring in any of the previous decisions. So the changes for this are relatively straightforward. One of the main things is that the execute selection set, rather than just returning data like it used to before, it now effectively returns like a three tuple or an object or whatever you want it to be. So it returns both the data, the things that are to be deferred, and the things that are to be streamed. It then it executes. So the data is the result of execution, and all of the defers and streams are not executed. They're not even started at this point, according to the spec. Now, keep in mind, an optimized server can choose to start executing those early if it wants to. That's unimportant to the spec. The spec just says, what order do they need to be delivered in? What does it need to look like is happening? So if there is only data and there isn't any defers or streams, then we just return everything like we normally would have done, return the defers and errors, and we're done. Otherwise, we create our incremental event stream, and this incremental event stream is what goes through the machinations of dealing with like the pendings, the next layer of defers and all of this. So this is almost like our run loop that handles here, and it is quite a lot of text, but it's all just for handling stream and defer. It also has things like this flush stream. I don't even know how this should be, and I have asked Lee as well, but he hasn't managed to get back to me on that yet. The flush stream is what's important for, like you were asking before, Rob, how do we know when we can send all these things together? And the flush stream basically says, send whatever the remaining incrementals are at this point, and all the pendings and all the completeds at this point in time. And importantly, other than this very final one here, the other ones are all optional. So if you want to optimize your server and you want to say, oh, I only want to do this every 100 milliseconds or something like that, you can do so. You have to do it at a point where flush stream is allowed, but then you can bundle everything up together as one massive list of incremental changes and send that all through as one payload. And that will be more efficient for the client in most cases. But other than that, the main differences to the actual existing spec text are actually quite small. So they're all relatively small changes that basically follows the existing flow. In many cases, it's things like where we used to have a field, we now have an object that represents both the field and some metadata about it, like whether it should be deferred or not. This, I guess, is a big change. What's this? Oh yeah, this is checking to see if every entry is deferred, then we'll skip it and do it later. Otherwise, we'll do it now effectively. But yeah, it leverages very much the existing field merging mechanics. And what that means is each field is only ever executed once. When we queue something to be executed later, like a field that is deferred, we will store the result of the resolver effectively, like the object value along with it into that next phase. Then that will get consumed, and then it can be garbage collected or whatever your language does to deal with that.
Yeah, I think that makes a lot of sense. The one thing that I'm concerned about is the fact that the paths don't line up with where the defers are, which I know you said is an explicit non-goal. Sorry. So I would like to get thoughts from the client developers on how that works for them. So Benoit, I don't know if you had time to look at it or not, or if you could in the next week, and also would like to get Matt Mahoney's thoughts too.
Yeah. Yeah, no, it's yeah, it's a bit hard at the moment to wrap my head around all this. Not completely sure if it's going to be easy for us to use that. The main thing I think for me on Apollo Kotlin is to know whether one particular fragment is completed or not, and yeah, not completely sure for now if that will be easy with this version.
Yeah, that shouldn't be an issue. Like knowing that fragments are completed should be the same as you effectively. If you use Matt's Dunder type name trick, so basically you put something in the fragment that is only in that one fragment, then you can just check for that. If it's present, then you know it's now completed by the time you've processed all of the incrementals in one individual payload.
I see. Yeah.
I have a couple of questions. So since we go in like layers, is basically mean even if we do alias fragments, it means we cannot do parallel execution of sublinks in any way. So basically, if you want some stuff to be faster, you need to push everything, you need to wrap everything else in like dummy defer. You have like 3 fragments and you want one fragment to be faster for some reason. So you basically need to wrap like 2 other defers in one more defer layer. Right?
Yes, that's correct. There is like, I haven't written it into the spec, and I'm not exactly, I was thinking about it again this morning. I'm not sure exactly how we would do it, but there is the possibility of having like defer again in the same selection set. At the moment, that all just gets collapsed to one thing. Basically, a field is either deferred or not deferred at each point. But we could add like, you know, levels of defer or something like that and split those up. More thought would be needed for that if we deem that that is something that is essential. But there, you know, there's some flexibility to look at doing things like that afterwards. Not afterwards as in later. I mean, like, you know, if this fixes many of the issues, then we can explore some of these if we feel that they're important.
All right. Okay, and I have another question or potential issue. Since I understand you don't like, I didn't read the whole algorithm. It's like pretty a lot of changes. But if can you open your proposal and example query? Yeah, so you have C twice, right? Yeah. So, and they they're on a summer level, so they like collected. But imagine you had like C outside of defer with like some fields. Question is, during execution, the resolver need to understand what directives are applied. So resolver need to get all the nodes, like nodes or directives in GraphQL.js. It get like an IST nodes and it can look into directives. So when, if we, for example, add like in synchronous part after B immediately, I can actually write. Here, yeah. If we add like here and inside one of here, for example, we add like some directive. Yeah, super useful feature. Yeah, so during this execution, resolver does resolver get like both nodes or not?
The question that you've asked is outside of the specification, because in the specification, you do not pass any selection sets into a resolver. That's a purely GraphQL.js thing.
Yeah, I mean, like, is set of fields presented, is like collection of fields happening or not before calling like first resolver of C? Like how directives get delivered is, yeah, it's like implementation details. But if like spec algorithms need to have collection of fields before execute, especially now since we don't have any duplication. is like all the fields collected in some set list
Yes.
or something else.
Just
Okay.
the same as they are currently, with the difference that at the moment you have a map that goes from the response key, response name, whatever it's called, to then a set of fields, right? So you did have like a bunch of selections, fragment spreads, fields. You've reduced that down to just a list of fields and then the response name for them. And validation at the moment basically says that everything in that set is roughly equivalent, right? Now what we have is, instead of having the field, we have this object that defines both the field and some additional metadata about it. So that is all part of the collect fields algorithm. Could you clear the annotations?
Yeah, okay. Yeah.
Thanks. Sorry, it's been a moment since I wrote this. So yeah, the field detail is the critical thing here.
Okay.
So instead of just having the field, you now have the field, the path, and whether or not it's deferred. So it's just effectively an extra layer of indirection. But other than that, it's all basically the same, yeah.
Okay. If everything gets collected, it means like directives are applied during execution, either way by passing to resolver. Or, yeah, for me it's important.
Okay.
Yeah. And another question: if you open like your RFC proposal, an example in it.
Yep.
So and response. Yeah. So if you have like, I'm trying to understand, if you have, for example, it's also not in your example, but if initial response includes C, like with some C free field, like you wrote to answer my previous question, second path will shift, this path will change to A and C or not?
Yes, it would actually. What you?
Yeah. Okay.
No, that's exactly what would happen. Yeah, this would become
Okay.
A, C, and then this would just become the selection set C1.
Okay.
So one of the really critical things here that, like Lee was discussing with me, is effectively we want to make sure that it's always a minimal merge. So we don't want to do deep object merging because it's expensive. So every time you get an incremental response in our system now, you can just do a simple shallow object merge. So here you, at path 0, you just merge this in. So you're effectively overwriting. There should not be an H property already there. And now you add that H property. At the path A, there was not already a C field there. Now you'd be adding this field. Now with what you just said, where we pull in C before, suddenly the path has to change because there would already have been a C. So now the selection has to be evaluated at this deeper path, which means then the data that you get through would be like this, and the C1 would be able to be written without needing any complex merging logic because it just gets pushed in. Same for stream as well. So
for list, you basically push into items.
Yeah.
And if C is, for example, like 3-dimensional arrays, we push into, we basically like creating new entry in incremental for every item of like 3-dimensional array, right?
Yeah, I think that's probably the case at the moment. We could look into like optimizing that further and making it so you could include multiple at the same time, but I don't think I'm too worried about that right now. So yeah.
Yeah, I also thought about this problem because like anything that push defer like to leaves, everything that emit duplicating like there is like deduplication of leaves and deduplication of like everything, of keys. So you implemented deduplication of keys. Any solution that implement deduplication of keys, it will push items it will push like defers to items of arrays of list, and by doing so we actually end up in situation server can be forced to inline stuff, which is weird. I also thought, yeah, I just wanted to highlight this. I actually think it's like this is a move in the right direction, but big problem with it is like, for example, you wrote C is a list, you wrote a query, everything works good until somebody else change another fragment that add C in initial response. And suddenly, instead of like previously, your stuff gets deferred as one array, compact representation, everything worked. Now, because somebody else fragment mentioned C, your defer shifted to items, and you get like entry for every item, which is not problem for a client. It should be handled, not the problem of application should be handled by a client, but server can decide it's like denial of service attack if every item in a big array creates entry in incremental, so it can unwind, as we discussed previously, as protection measurement from having huge incremental. And this like is strange. In your fragment, everything is worth. Somebody else change another fragment, and suddenly you defer. Your data gets unwind instead of being deferred, which is weird. What I wanted to mention, I think if we go with any solution that do deduplication of keys, we need to figure out how to do batching of items in a list. Otherwise, it's not feasible. It's a problem.
So if I understand you correctly, if we imagine that we've got a field inside of let's say a Z that is a list, you're effectively saying you're going to end up with you know, foo1, whatever, it doesn't really matter.
Yeah.
So you're effectively saying you're going to get a bunch of these, right? Rather than having the list come through as an individual thing. Which, yeah, is, I think you're not wrong. That is exactly what would happen in the current proposal. There are potential options that we could consider for dealing with this, like I was saying before, like batching. But at the moment, like, I'm okay with this. And I don't think that this would be really a denial of service concern from the server's point. I mean, arguably it could, but really all we're doing is we're putting this amount of extra data instead of a comma. It's just, you know, it's not a huge amount of data to put in addition.
They are batched because they would have to be inside the same response in the same incremental array, right?
Yeah, that's already guaranteed. So they will be like this. They will have to come through in one single incremental, again, this should have been a square bracket, incremental list like this. So it's already batched, and that's actually coded into the spec itself with the, you know, everything needs to be done at once. Yeah, was that
Yeah.
actually your concern? Like the actual batching of it like this?
Yeah. Imagine, remember like when I proposed to add like incremental field initially, and we had like big discussion about saying you should not inline everything. Like if you want to deliver stuff in the first batch, you need to put it in incremental. You cannot inline it in data. And your argument and everybody else argument against it was that we create entries inside the incremental. So, and it's a problem. So that's
was
why
a problem with the way that it was previously specified, because there was a lot of duplication in that, and you could multiply, like my example I think back then was like you could take a response from like 1.8 megabytes up to 48 megabytes just in that initial payload. But that wouldn't be the case anymore with this, with what I'm proposing here, because of, as you say, the deduplication of not deduplication, the keys, each key is only like handled once. There is none of that repeating of those leaves.
Yeah, but keys are put in path.
Yeah, so the maximum problem that you're going to have is the depth of your query, which often will have a limit on depth, right? Times the length of the possible key, which is technically unlimited in GraphQL, but I think it would be very reasonable for people to add validations that say, if your key is longer than 100 characters, you're probably, pushing it a bit. So the longest path is going to be in the region of, let's say, 500 bytes. So yeah, you can definitely inflate
multiplied by number of items.
Which, let's say 1,000. So you've got like 500 bytes times 1,000. So it's like 500 kilobyte. It's not the 48 megabytes that we had before. It's a much, much, much lower attack vector than what we were previously discussing. And even the numbers I just said, they're still, they're still large. Like deferring inside of 1,000 items is already something that arguably you should, pagination limits and such.
So question now. So basically, instead of like inlining stuff, we can now basically put it even. So like what a server would do if it's decide to optimize stuff? It will inline it every level. So like if I executing like first deferred layer and I see some data is already provided and I say like, why not I inline it on that level, right? And skip it from next defer level.
So you have to be extremely careful with this approach. So the rules that I figured out for this are effectively each time you see a defer or a stream directive, you may, as the server, ignore it and pretend it's not there. But that's it. You can't do it on a field basis because otherwise it would break the fragment modularity issues. So it has to be done based on the actual directive itself, like effectively at a fragment boundary, because directives, defers applied on a fragment. For stream, obviously it's a field, but whatever. So you can ignore the defer. If you do ignore the defer, then it's ignored for every instance of that. It's not like, oh, we defer the first 100, but then after that we inline the others or anything like that. Like you either throw it out entirely or you use it for everything.
So
that's on a defer inside of a list. You wouldn't be able to defer some list items, but others. Is that what you mean?
I think inside of a list it would technically be okay. And
Because the paths are different.
just to be clear, I haven't written any of the allowing of this to be skipped into this RFC proposal so far. So like at the moment, if there is a defer, it must be honored. If there is a stream, it must be honored. But I think we can definitely soften them according to various rules that we come up with. But yeah, it must be done based on the directive itself. And yeah, Rob, I think you're right that because the path makes it, so long as the path is unambiguous, it should be okay. It's, you just don't want to break fragments.
If you have two defers under the same object with different selection sets in each one, I know before we had said that like because they would have the same path, you would have to either ignore both of them or keep both of them. But would that be the case here? Like could the server decide to inline the first two defers but honor the second two? I'm guessing probably because
it can treat every individual defer as its own thing and choose to ignore that defer.
Right. And that shouldn't cause any problems for clients because clients are going to have to use the type name hack to understand anyway.
Yes, and I think it's actually really important that we don't actually link the client to tell that it relates to this one specific defer or anything like that, because it's going to rule out a huge amount of potential like future, I don't know, optimizations or other flexible things that we want to do. The client shouldn't specifically think of this defer being a thing and this defer being a different thing. Like all the defer is saying to the server, I'd like it if you were to send this later. Like you don't have to, but it's up to you. But I'd really like it, you know, if you don't worry about sending this with the first payload. It's a request as much as anything. It's not actually like a concrete thing. It doesn't have a name. We've got rid of labels. So yeah, I don't think we should tie them together. So from the client point of view, when it receives data from the server, it should know this path has more data coming. It's not complete yet. And that's about it. That's all the client should know.
Yeah. Again, my concern is, which maybe it's fine, is about specifically for clients that have fragments tied to components and how the client is going to know when to render. So with relay, when you're rendering a component, that component has its fragment with it. And it's the parent component that applies the defer to the spread for that fragment, which is nice because you could have two components in two different places in two different parts of your data, and the parent could decide to defer one but not the other. And so just clients needing to understand they need to like render the loading indicator until this defer is done. Yeah, so maybe that means a compiler adding the type name hack, or you have to do it manually, or but yeah, that's just what I want to get input from the client developers.
Yeah, I agree. I did actually reach out to Matt to ask about this and say what he thought of it, but he's been super busy on other things, so he hasn't been able to think about it. But he's hoping to at some point soon.
Cool.
At the moment, like Matt's type name hack is basically the best solution that we have for this and for this problem in general, like especially if you're using, say, the skip and include directives. Like this is already a problem that you have in the GraphQL space, knowing whether a fragment is complete or not. So this effectively says this is a problem that we already have in GraphQL, and we should solve it in the way that we will for the rest of GraphQL, and it's not specific to stream and defer. Just we're not going to introduce another problem here, which is why we mandate that all of those incrementals come in together. But if we were to later have like labeled fragments or things like that, that should work in stream and defer just the same as it would in regular GraphQL. So it should continue to honor all of these things. Yeah.
Okay. You had also mentioned in Discord that you can tell it to independently run two potentially slow sibling fields with aliases on the parents. Yeah. I'm a little surprised by that. I thought that it would work. Maybe can you explain it?
Sure. Okay. So let me just try and scribble something together for this. So trim a bunch of this away. So effectively, what we're saying is thing 1 and thing 2, right? So at the moment, you might want to say, do something like this, where you have an alias, another alias, then you have a deferred thing inside that is expensive. I'm going to get rid of this directive as well, because that's going to be confusing. In fact, let's just change this to slow field 1 and slow field 2. So at the moment, these two things exist at the same defer layer, like they're each, this is inside of one defer and this is inside of one defer. It doesn't matter. I mean, you could even have done it like this. Gosh, too many curly braces everywhere. Even like this slow field 2 is inside of one defer, and this slow field 1 is inside of one level of defer. So they belong at the moment in the same thing. There's technically nothing that strictly enforces, I mean, the way that I've written the spec at the moment puts them in the same thing. We don't need to have them like that because they are like independent. They can be split apart from each other, so long as they are entirely independent. But if you had a field A, oh gosh, sorry about that. I must have pressed a key. If you have a field A, it makes it much more clear why that's the case. This must always be delivered together for fragment isolation reasons, right? Because you might want to have like the frag 1 type name. I'm going to put commas in, even though they're ignored, just because it might make it easier for people to understand. And then this would have the frag 2, for example. Now, this A must only be ran once, right? And that's the same A as this. And why have I used A? Let's use Z just to split that up. So the A.Z here and the A, oh no, that's not true, because this is alias. Right. So technically we could split that up as well. Yeah. There could be something that links them together. So if I go back to what we had before, like this, sorry, I'm doing a lot of on the fly thinking here.
Yeah, I'm not sure what the spec says, but GraphQL.js definitely, like in this case, A is getting executed twice and the child fields are getting resolved independently.
Yeah. I think this is what I was trying to say. Okay. Effectively, the foo in both of these would need to only be executed once. So there could be a thing that ties them together for some reason. Even though the slow field 1 is inside this path and slow field 2 is inside this path, technically, you know, the foos join them. We could potentially make it so that, like, imagine this, these don't have defers, and instead we just add a defer here. There's nothing that would stop us at the moment, I think, from making these two things independent. In the current algorithm, they are treated as the same, but we could make them independent if we can figure out that there exists no, you know, foo that joins them together as the same thing. So long as they are completely independent paths and the same paths won't appear in the same fragments, then we could split them up. They're just, you know, there isn't an accommodation for that in the spec text that I've written currently. And also, I'm not sure how you would do it.
I do feel like that's pretty important. I mean, I guess I don't understand why they're linked together if if their paths are completely different. Because of the alias on the thing one, thing two aliases.
The reason that they're different is because effectively the way that the algorithm that I've written currently works is it just does field merging and it says, here's the stuff to run now, here's the stuff to defer. And that's it. Like the stuff to defer is just one thing. We could potentially make it so that stuff to defer is, you know, a set of independent things that do not have overlapping paths, but writing the spec text for that, I think would be quite challenging, like understanding exactly what the circumstances are in which they end up being independent, factoring in that these are like often nested selection sets. You know, the fragments need to still be consistent. And I don't know, whatever. I think it would be challenging, but I think it's possible. It's definitely possible. I don't know how I'd write it.
Okay, I think I need to spend some more time with it. But when you get down, so when you execute this, foo is getting merged together. That's the same field. The first pass is collecting fields at the root level, and that's going to return foo, thing one, thing two, right?
Yeah.
Now you execute foo, you execute thing one, you start executing thing one, you go into that selection set, and now you should only be getting, I guess, frag one, Z, and slow field one now, right? And with slow field one being deferred?
Yeah.
And you haven't even started looking at thing two yet, right?
Mm-hmm.
But even though now thing one is completely resolved for the initial payload, except with everything except for slow field one, we still don't start executing slow field one until we finish going through thing two. Is that the way it works?
Yeah, exactly. We do the entire field collection. We don't go into the selection sets of defers. So if these slow fields have their own selection sets, we don't navigate those. We only go as far as the deepest non-deferred selection set. So this one in this case. So we can see the frag one, the Z, and we see the slow field, but we do not follow its selection set. Similarly, we see the frag two, the Z, and this field, but not its selection set.
So it's literally everything that's only under one defer in the entire query has to get returned in the same incremental?
At the moment, yes.
And to clarify, nothing is inside like a second layer is started to executing until like first layer, until like previous layer is finished.
According to the specification, yes, but an optimal server can choose to do something different.
Okay. But semantically, everything can work like that. It's according to a spec, and from external observer, it look like that. Everything else is like optimization.
Yes.
Okay. Why we cannot? We have like has next. Why we cannot just use some marker to signalize level is finished? Why we need to physically ship everything into one payload? Because like as we discussed previously, we can, if client gets everything batched up, we cannot change it in later like specs, in future, because client is expect everything being batched. So it basically mean like it would be not impossible, but it would be strong argument against adding like any features that ships stuff in parallel, like independent, like on the same defer level ship, like some stuff earlier. Strong argument against adding like any such feature would be that client expect stuff being batched.
Yeah, so the spec text guarantees the order of the payloads that will be received by the client, roughly. Obviously, like streams and like parallel defers that are on different list items, they can come in any order according to the spec. But within like regular object selection sets, we specify exactly what order things come in, and it means that the parent object must always be present before we send the next layer, and that's not something that we explicitly state. That is just a property of the algorithm, right? It's one that we've already discussed, but it's a property of the algorithm. So if you want to start executing stuff early, you can absolutely do that, but you must still deliver the payloads in the order that the spec says you must do so.
One positive thing I will say, so we kind of had like mental model, real mental model, not bunch of like rules, but mental model. Back when we had labels and full shape, meaning like if you specify label and defer, you will get all the fields on the defer as the same batch. It's kind of, this mental model made sense. It had like bunch of problem, made sense. When we shifted through a bunch of like half measures, which I wouldn't call them mental models, it's just like set of like rules. And now it's finally look like a mental model. I still think it's have like a problem, but at least it's finally mental model. If you in your brain, if you understand like defers as like layers, and you understand how GraphQL merging works, now it's like you understand how this thing works even without like reading your algorithm. It's like the thing is like logical, and it's not rule based. It's kind of like one principle. Everything under the same defer level execute like as one thing, and everything, and it's treated like it's recursively. Initial response of like you have initial response, when you have defer with initial response and subsequent defer, inside that defer you have initial response and subsequent defer. So finally it's like mental model. So on that basis it's like a progress. And I think we can figure out like edge cases and problems, but I think some of them like important, like ability, at least like some understanding how in future we will add like parallel delivery, because now in current state, what you discussed with Rob, it's like people would want it. But yeah, and maybe we'll add the new spec version, but I don't see how.
Well, thank you, Ivan, first. One of the other interesting things about this is if we want to, we could like effectively ship this as is. And then when we want to do those splitting up like the priority of the defers, we could do that as a separate change and it wouldn't change anything from the client's perspective. The payloads they would receive would be different, but because we don't link the individual app defers to something that we concretely give the user, we just tell them there's more stuff coming at these paths, and here's the data, and we ensure that the fragments that we give you are consistent and delivered together. If we have these two independent fragments that have no overlap whatsoever, then in a later version of the spec, we could deliver them separately in either order without breaking any existing clients, which I think is really nice.
A problem with that, it's like clients need to detect if fragments get shipped. Yes, they can do with alias trick from Matt, but at the same time, they can use like layering thing. Because like alias trick basically force you to modify query, and it's make payload bigger. So currently, like if server works as you write in spec, basically you can track delivery of fragments based on layers shipped. So you understand that if this fragment is deferred, and it's like first level defer, you need to wait initial response and one more package, and you know for sure fragment is fulfilled. If your deferred fragment is inside like another defer, you need to wait like initial response and two more packages. And like I'm worried that
I understand what you're saying, but I don't think that is a guaranteed, like we shouldn't, or if need be, we should put spec text in to make it say that that is not a guaranteed property of the system. It currently holds, but it isn't guaranteed to hold into the future, because that is effectively the client looking at what the current state of the specific algorithms are and then assuming that those algorithms will never change. Whereas what they should be doing is looking at the data we're sending them and only honoring like what we say is true about that data.
Hey, sorry, I need to jump in because I need to leave for another meeting, but there's another working group on Thursday. I think that maybe we should talk through this with a bigger group then and get more opinions from there. What do you think?
I think it's probably quite a large thing to present at the normal working group. Like, because you have to give people enough backstory. I actually have, I didn't show them, but I actually have a bunch of slides that explain like the underlying of a bunch of stuff that we talked about in this group previously. So I could use that as a starting point, but I think it would be like a 45-minute session.
Yeah. Okay. Maybe let's keep it with us for another week or two and see if we can get more, solidify it more.
I think that would be the right approach. See if anyone on this working group has some major pushback first, and then, as you say, maybe to the next primary working group, we'll add it there in April.
Okay, I have to jump off. You guys can keep talking if you want, but thanks a lot.
Thanks, everyone.
Yeah, bye.
I missed it because I made a mistake with the time zone.